Hi, welcome to my video on find all possible values of cos and sine in degrees and radians. Find all possible values of theta. We're going to look at the circle which has a radius of 1, a unit circle, and that means that this point right here is 1, 0. This point is 0, 1, and this point is negative 1, 0. And this point is 0 and negative 1. So this is a 0, 90, 180, 270, 360. If we go this way, it's a negative 90, negative 180, negative 270, negative 360. And we're going to look at the equation x equals cos theta. And cos is the x, so on this circle, we have 0 degrees right here. So x is 1, 0 degrees right here, x is 1. And at 90 degrees, x is 0. And at 180 degrees, x is negative 1. 270, x is 0. 360, x is 1. And at 450, x is 0. 540, x is negative 1. 630, x is 0. 720, x is 1. And if we go the other way with a negative rotation, at negative 90, x is 0. At negative 180, x is negative 1. At negative 270, x is 0. And at negative 360, x is 1. So the graph is drawn, and notice we're tracing out all the points that it's going through, and leaves here, notice it's going to go down. It follows the pattern. Leaves here is going to go down to 0, negative 1, back up to 0, back up to 1, and then it starts to come down again. And you'll notice that the cos graph is a sideways C. From 1 right here to this 1 right here, that's a C, a sideways C. And from 1 here to this one, you have another C. So notice from right here you have 1 to 1, this is a C. So notice that, let's look at the equation x equals negative 1. And x equals negative 1. Negative 1 is right here. So x is negative 1 all the way along on this line. So this line is x equals negative 1. And at negative 1, if you take these two equations and put them together, you'll get cos theta equals negative 1. So cos, this is the cos graph, and at negative 1, we have a negative 180, we have 180, and we have 540. So cos theta graph has a negative 1 at negative 180, 180, and 540. And notice that between here and here, there's 360 degrees. And between these two, we have another 360 degrees. So notice it repeats every 360 degrees. So once the negative 1 occurs here, go 360 degrees, we get another negative 1. Go 360 degrees, we get another negative 1. So that means the period of cos theta is 360 degrees. So let's look at what the equation y equals sine theta. And sine is the y, so at 0, y is 0. And at 90, y is 1. At 180, y is 0. And at 270, which is here, y is negative 1. and 360, y is 0. And if we keep going around, 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 we go to 1, 0, -1, 0, and we go back up to 1. And if we go this way, at -90, y is -1, -180, y is 0, -270, y is 1, -360, y is 0. So the sine graph is traced out like this, very similar to the cosine graph. The only difference is that the two of them have the very similar. So you go like this. But the sine graph starts at 0, goes to 1, goes to 0, goes to -1, goes to 1. So the sine graph is, if we want to look at the equation of y equals 1. So y is 1 right here, and y is 1 all the way along here. So this equation is y equals 1. So if this is the sine graph, which is the sine graph is a sideways S. Notice the sine graph is S. There it is, starts at here, 0, goes up, there's the S, and then it repeats, another S. And if you start here and come back, there's an S. So it's, if you start at 0 and make an S, then there's one cycle. So the equation, y equals sine theta equals 1. If y equals sine theta and y equals 1, the equation y equals sine theta equals 1 occurs at -270, y equals 1 at 90, y equals 1 at 450, and y equals 1 at 810. And notice there's 360 degrees between these two. And there's 360 degrees between these two. And there's 360 degrees between 450 and 810. So it, again, the sine graph has a period of sine theta is 360. It repeats every 300. So the period of the cos graph and the period of the sine graph is 360. Let's look at that a little bit further. Let's take an initial measurement of an angle at 30. So if the period is 300, if we take 30 and add on 300, then we should get the same value. And if we take that and add on another 300, we should get the same value again. And if we go back the other way, if we take 30 and subtract 300, we should get the same value, because there's 300 degrees between this one and this one, 300 between 30, and if we make that 390, there's 300 here, and if you take 30 and subtract 300 twice, then you're over here. So that means that if this angle is 30, this angle is 390, and this angle here is 750, and this angle right here is -130, and this angle is a -690. Notice there's 300 degrees between each one on any of the cos graph or the sine graph, because the period is 360. Well, let's look at that a little tiny bit further. Notice this is 30, 360 once. And this one is 30 with a 360 twice, 1, 2. And this is 30 with a 360 no times, because it's the initial. And this is 30 plus 360, and a negative 1. And this is 30 plus 360 degrees, negative 2, because it's 1, 2, 2 negative 360s. And there's 1 negative 360. So notice the pattern that theta is, whatever your initial one is you have 30 plus 360 n, where n belongs to the integers. So 30 is the initial angle, and if you take n, notice n is 1, then you put a 1 in here, you'll get your 390. Put a 2 in here, you get your 720 plus 30, 750. So for any angle, theta, if you take 360, n, and n belongs to the integers, you will get, for any angle that we do, if you add on 360n, where n belongs to the integers, notice the integers are 0, 1, 2, negative 1, negative 2, etc., you will get all the values on your cos or sine graph from the initial. So that's the pattern. The initial measure is 45, so 45, if you want all values, is positive 360, which is the period, times n, where n belongs to the integers. If you got 120, you got 120 plus 360 n, where n belongs to the integers. If you have 180, you take 180 and you add on the cycle, which is 360 times n, where n belongs to the integers. And if you got 0, 0, add on 360 n, where n belongs to the integers. But 0, we can also say, instead of 0, we can just write down 360 n, where n belongs to the integers. Because you got 0, 0 added on to 360n is still 360n. And we have a notation here, 90 plus 360n, where n belongs to the integers. Find theta if you have a negative 280 less than theta less than 900. That means we want, for this notation that we're talking about, all possible values, we're talking about, we want it between negative 280 and 900. Well, let's look at when n is 0. So 90 plus 360 times 0. So that's 90 plus 0, which is a 90. The initial, when n is 0, we get a 90. What about when n equals 1? 90 plus 360 times 1, that's 90 plus 360. That gives us 450. And we want to go again. Why? Because we want it between up to 900. So what about n equals 2? 90 plus 360 degrees times 2. 90 plus 720. And that's an 810 degrees. And if we went one more, then we get 360, would it be too large? And what about if n is negative 1? So 90 plus 360 times negative 1, 90 minus, let's make that a minus because a negative times positive is negative, 360 would give us a negative 270. And if we go again, it'd be too far down. So these are all the values between negative 280 and 900 that make this true. So negative 270, or 90, 450, and 810 are the four angles that fit this notation here for all possibles. Knowing this is what we have to go by. There are infinitely many more, but we only want the ones between negative 280 and 900, and there's the four of them. Okay, we'll use that to our advantage to get all possibles. Find all possible values of theta in degrees when cos is equal to -1. Okay, cos is -1. Well, let's see, we have a circle. Cos is the x. So x is a -1, x is 1, 0. And right here, x is -1, 0. Right here we have a 0, 1. And right here we have 0, -1. So x is -1. Cos is -1 at theta equals 180 degrees. Now, that's one of them, but all possible. So all of them is 180 plus 360, and where n belongs to the integers. So that's all of them. So you take 180. If you put 0 here, you get 180. Put a 1 here, you get a 360 plus 180. Put a -1, you get 180 minus 360. So this represents all the values on, if you graph the cos, that a -1 would be all of these angles here. Number 2, sine is √2/2. And before we start, sine is positive, so we have add sugar to coffee. And sine is positive in quadrants 1 and 2. So let's draw it in quadrant 1 right here. And let's draw it in quadrant 2, which is right here. And notice this is √2/2, so we have a √2/2 gives us a 45-degree angle reference, and √2/2 gives us a 45-degree reference. So if I drop the perpendicular to the x-axis, sine is the y, so y is √2/2, and this is √2/2. This is 1, so the reference angle is 45. Reference angle here is 45 also, because sine is √2/2, which is the y. The x is -√2/2, but the reference angle is 45. So that means that in the first quadrant, the reference angle is the theta. So we have a 45-degree angle. And in quadrant 2, the reference angle is 45, but theta is 180 minus the reference angle. So theta is 135. So that means all possible values for this one is 45 degrees, add on 360, and where n belongs to the integers. And for this one, all possible ones is 135 degrees, add on 360, n where n belongs to the integers. So if you were to put, again, if you were to put in as 0 and 1 and 2 and 3 and plug it in your calculator and do sine, you would get √2/2, which is equivalent to 707 if you did your calculator. And that would be the same here. So these are all the possible values where on the sine graph where you get √2/2. Number 3, cos is a -1/2. And let's see, we have add sugar to coffee. And cos is the x. So cos is positive in 1 and 2, so it's negative in 2 and 3. So it's negative in 2 and 3. Let's draw the circles. And we have in quadrant 2, there's the terminal arm. There's the perpendicular to the x-axis. In quadrant 3, there's the terminal arm perpendicular to the x-axis. And cos is the x, so x is a -1/2. So this side is √3/2, and that's a 1. So that means that opposite √3/2 is 60. So the reference angle is 60. That means the reference angle here is 60. let's check. The x is a negative a half. The y is root 3 over 2, but it's negative going down. Hypotenuse is 1, so that's a 60 also. So in the second quadrant, theta is 180 minus the reference of 60. So that's 120 degrees. And in the third quadrant, theta is this rotation. So theta is 180 plus the reference, which is 60. So that's 240. So for all of them, you have 120 plus 360 n, where n belongs to the integers. And for this one, if you have all of them, you have 240 degrees plus 360 degrees n, where n belongs to the integers. That's all these values here. Again, when you put any value, any integer in, you will get an answer. So when you plug it into your calculator and do it here, you will get a negative a half for both of these. They're all possible values. And what about, we did them in degrees now, what about doing them in radians? Well, let me show you. Sine is 1. So sine is 1. Sine is 1. That means y is 1, so that's right here. X is 0, y is 1. X is 1, y is 0. X is negative 1, y is 0. X is 0, y is negative 1. So the only answer here for theta in the first rotation, theta is 90 degrees. So 90 degrees is, again, that's a degree. We want a radian. So in terms of a radian, theta is multiplied by pi over 180. 90 in once, 90 goes twice. So 90 is pi over 2. But we want all of them. So notice if we want all, and we want them in terms of radians, so it's pi over 2. So 360 degrees is the same as 2 pi. So it's 2 pi n, where n belongs to the integers. So instead of 360 degrees, 360 degrees is equated with 2 pi, because 180 degrees is a radian of pi. So let's do some more. Cos is root 3 over 2. So let's see, we're add sugar to coffee. Cos is positive, which is 1 and 4. So we'll draw them in quadrant 1, and we'll draw them in quadrant 4. Perpendicular to the x-axis. Done. Cos is the x, so the x is root 3 over 2. The y is a half, and opposite a half is 30. So the reference angle is 30 degrees. And also here, cos is the x, so it's root 3 over 2. But the y here is a half, but it's negative. But opposite 1/2, you still have 30-degree reference. And so the reference angle is 30 in the first quadrant. Theta is the reference angle, so theta is 30 degrees. And as a radian, 30 times pi over 180 to convert it. 30 once, 36. So 30 is pi over 6. So we want all of them. Then we would go pi over 6, add on, not 360 degrees, we add on 2 pi n, where n belongs to the integers. So we're not doing degrees, we're doing radians. So instead of 360, we got 2 pi. And this one here, we got the fourth quadrant, it's all the way around. So let's get the answer. Theta is 360 minus the reference. So that's 330 degrees. And we multiply by pi over 180. And the zeros cancel, is divided by 10. 6. 3 into this one goes 6. 3 into this goes 11. So that's 11 pi over 6. And we want all of them. So we would go, just bring it up here, 11 pi over 6, add on 2 pi n, where n belongs to the integers. And hopefully you're getting the hell of what we're doing here. And sine of theta is 1/2. Again, where are we? Add sugar to copy, or the cash rule, but the cash rule starts in quadrant 4, CAST. All sine, tan, cos, and sine is positive in 1 and 2. So we go to 1, we'll go to 2. So quadrant 1, perpendicular to the x-axis. Quadrant 2, right here, terminal iron, perpendicular to the x-axis. And sine is the y. So the y is 1/2. That means the x is root 3 over 2, hypotenuse 1. And the y is 1/2. X is root 3 over 2, but is negative in second quadrant. And so opposite 1/2, so the reference angle is 30. Reference angle equals 30. First quadrant, theta is the reference angle. And a radian, we want it in terms of radian, multiplied by pi over 180. 30 once, 30 goes 6. So that's pi over 6. So we want all of them for that angle. So we have pi over 6. Add on 2 pi n, where n belongs to the integers. And we do this one right here, second quadrant. Theta is 180 minus the reference angle, so that's 150 degrees. And 150 degrees is multiplied by pi over 180. 10 cancels. 3 and 18 goes 6. 3 and 15 goes 5. So that's a 5 pi over 6. And we want all of them. So we'll add on 2 pi n, where n belongs to the integers. And again, notice the reference angle is 30. 30 is a pi over 6. Notice the answer. Here we got a pi over 6. Add on this. Notice we got a pi over 6, which is the reference angle. That's a 30. Pi over 6 is 30. 5 30s makes 150. So each of these answers here and right here has to have a pi over 6. But we want all of them, so it's 2 pi n, where n belongs to the integers. And 2 more. Find the values of theta. And notice that we're dealing with radians. And look at this one. We're dealing with degrees. So now we're restricting it. So let's have a look. Sine is the y. Where is y? -1. So x is 0, y is -1. That's right there. So that means theta is 270 degrees. And 270 degrees multiplied by pi over 180. The zeros cancel. 9 is 2. 9 divided into here is 3. So that's 3 pi over 2. So think about it. If we take the answer is 3 pi over 2, add on 2 pi n, where n belongs to the integers. That's for all of them. But we only want the ones between -2 pi and 4 pi. So if we take 3 pi over 2, which is one of them, and we take 3 pi over 2 and add on, when n is 1, we get 2 pi. So that's 3 pi over 2, add on 4 pi over 2. So that's a 7 pi over 2. There's one above it, and below it is 3 pi over 2. Subtract 2 pi, because this is when n is -1. So that's 3 pi over 2. Subtract 4 pi over 2. Common denominator is 2, so it gives you negative pi over 2. So the three answers are negative pi over 2, 3 pi over 2, and 7 pi over 2 are the values of pi between these that satisfy this equation. And one more. We want the answers in degrees between 180 and 1,000. So let's see where we are. Let's see. Add sugar to coffee. Sine is negative. Sine is the y. Sine is positive in 1 and 2. So it's negative in 3 and 4. So it's negative in 3 and negative in 4. There's 3. And here it is in terms of 4. Perpendicular to the x-axis. Done. Root 2 over 2. I know that root 2 over 2 has a reference angle of 45. Don't even have to look at it, but the two sides are the same. That means that we have third quadrant. So here's theta, this rotation. So theta is 180 plus 45, which is 225. And in this quadrant, theta is all the way around the fourth quadrant. It's 360 minus 45. So it's 315 degrees. But what about this? This is where sine is negative in 3 and 4, but cos is negative. So cos is positive in 1 and 4. Cos is negative in 2 and 3. So cos is 2 and 3 negative. Sine is negative in 3 and 4. So we can only look at, this is not where we're looking at. We're only looking at the 225 because we can't look in quadrant 4 because it's cos is negative in quadrant 3, sine is negative in quadrant 3, so we don't look at this one. So we only look at the 225. So 225 degrees, add on 360 n, where n belongs to the integers. That's all of them. But if we do 0, we can't go negative. So if we put 0 in, when n is 0, we'll get 225. When n is 1, we'll get 225. Add on 360. N is 1. So that is 585 degrees. And when n is 2, we'll get 225 plus 360 times 2, so it's 225 plus 720, so we'll get a 945 degrees. So these are the three values of theta that fit between 180 and 1,000. So notice the three answers. So this answer is not good because it only fits where sine is negative and cos is negative. Both cos and sine are negative in quadrant 3. So even though this answer might, if this was not here, then I would have to do this one too. But this quadrant 3 is the only angle. 225, adding on all possibles and then working out the answers that fit between here and here. And hopefully that makes sense. I tried to explain it as best I can to make so that you understand. And if you understand, good. If you like that, click on the like button, subscribe button, visit my math website, www.mathfullyexplained.com, to find more information about me, my videos, and the content that's on my YouTube channel called Math Fully Explained. Thank you for viewing my video. Bye-bye.